Hello, everyone, and welcome to the first week of Devtoberfest 2024. So today, it is one of the four Mad Thursdays. So today is all about machine learning, data, and AI. And before we start with the session, let me remind you about the Devtoberfest page in SAP community to know more about the various activities for Devtoberfest. Check it out to win points for the grand prize, which is a retreat at an SAP TechEd Roadshow stop in 2025. The current session is about getting started with agents using SAP Generative AI Hub. And let me introduce today's speaker, Mathis Boerner. So Mathis is one of our extremely qualified data scientists in the Deep Learning Center of Excellence, and I'm super excited to have him here today to tell us about large language models and agents using Generative AI Hub. Welcome, Mathis, to Devtoberfest, and now over to you.
Yeah, thanks for having me. Yeah, and it's a good reminder. I have to update my profile because I switched my job recently. So I've been with SAP for 3 years now, or 3.5 years, and always worked as a data scientist. I have an astrophysics background. I have a PhD in astrophysics, but started during my astrophysics study, started with machine learning and then ever stayed in machine learning and AI, and worked as a data AI scientist in industry, and now I switched side and went to the dark side, to the product side. And now I'm part of the product management team for AI Core and SAP Generative AI Hub. And today I'm delighted to talk not so much about the product that I'm working for, but more about AI agents. But I also, it's a product I'm working for, so I have to bring in some generative AI hub capabilities. So yeah, let's get started. Maybe to set the scene a little bit and to not directly jump into some theory about agents. At the moment, what a lot of people do, and also most SAP features being released are about prompting existing models. So it's often about embedded AI, and you do some RAG, you do some in-context learning, and you use the LLMs or the models like they are, the base models. And the thing that you tinker with is the prompt and the software before and afterwards. And it's cool. A lot of amazing things can be done. But if you zoom out a bit, it's just the beginning. So next step after just prompting existing models, it's more about extending and adapting models. And adapting could mean fine-tuning, so you create specialized models. And extending is, for example, doing advanced patterns like AI agents, and this is what we want to talk about later more. And this is then also, would see, like, at least for SAP, it's only one step, and the next step, and we're already working on the next step, is build our own models, special purpose models. So already mentioned, at the moment, a lot is about releasing features built on prompt existing models with zero few-shot learning, in-context learning, or RAG, so retrieval augmented generation. But as mentioned before, today we want to talk more about the next steps, about extending or adapting models, more specifically about AI agents. And from SAP perspective, one crucial difference or shift if you work with AI agents, and I will show an example in a bit, and then also try and explain not the basics, but some fundamental things about agents. One fundamental shift with AI agents is that if you prompt models, you often embed it and you bring GenAI to the product, GenAI to your system, and integrate it into the product. And with AI agents, it's more the other way around, or the promising part of AI agents is mostly about doing it the other way. So you integrate your product, you integrate your system into the GenAI, and let GenAI use the product or the system as a tool to achieve things, to fulfill requests of the users. And it could be multiple products, so you can fulfill requests across different products or systems. So it's really a shift that's not about integrating Gen AI into the product. It's more about integrating the product with your Gen AI model. And how to do this and how this could look like, I want to start with a video. So I will explain later more details on what is done here and how it's built. And upfront, it's a showcase. It's to make the benefits or what AI agents can do more tangible, especially in the SAP context. And it's directly connected to what I just said before. It's to show what can be done if you bring your products to Gen AI and let Gen AI work with your products or your systems. So what you can see here in the video, I will stop it for a moment. So the idea here is to have an interface where you just type in what you want. So here is create a new production order with material. Then it's a material specification, a production plan, manufacturing order type, total quantity, and some end type. And I have never ever created a production order myself before. I always worked in the AI unit and not for S4 in the manufacturing unit, or so I don't know how to do it. But what I know how to do is I know how to bring the API spec for this to an LLM and let an LLM come up with a solution to do how to do this task. And this is what you now see here running. I will, as I said, I will explain later the details of what's happening here. So see some steps are happening. There's a plan on what to do. And then maybe we can skip here a bit ahead. So this, yeah. So here you can see this is the final answer, and we will go to the intermediate steps later. So it does it. So in the end, it figured out how to do it, and then it sent the answer as the ID of the newly created production order is blah, blah, blah. So what was input to the model is just my request and the API spec for the endpoint. The rest was done in an agentic workflow. So it understood, the LLM understood the API spec and then had some calls to use it to run the HTTP calls, some tools to do HTTP calls. And then it sent the request to actually create this manufacturing order. And those kind of workloads, I mean, if you just want to have a function creating manufacturing order, you would hard code it, and you better should hard code it. But there are billions of different combinations of doing API calls, and not for every single scenario we can build a hard coded function. For the most common use cases, we can hard code it. But there's so many different things you could do or combine and sequence of calls depending on what you try to achieve. This cannot all be hard coded, and this is where agentic workflows try or are promising to help here and to offer high value capabilities. So here we will explain later, or we will take a later detailed look, but just to give you an idea of what we are looking for and what we want to do with agentic workflow, or an example for agentic workflows for SAP. Okay, so now we will go back and I will talk more generally about AI agents. Then we're going to build one ourselves. And then later, hopefully I have enough time to go through the example again, and then hopefully everything becomes a bit clearer. So AI agents, like this term is used quite a lot. And I would say we could talk about its agent washing at the moment in the industry. Everything is now an agent, even a very, not simple in the sense of bad, but even like RAG now is often called agent or agentic. So maybe the first question is, what are AI agents, or is there a definition for AI agents? So what I did, I just Googled for what is an AI agent and took like the first 8 hits. And then we also have an internal white paper about agents and took the definition from there. And then you don't have to read the definition here, but what stands out is all of the definitions have 3 common things or characteristics of systems. What they say, then this is then an AI agent, or this are characteristics typical for an AI agent. And the first one is autonomy. So the system needs a certain level of autonomy. It has to operate independently without human intervention. And then second criteria is environment interaction. So the system has to gather data and affect changes using sensors and actuators. So it has to interact in both directions, and often not only like fetching data from the environment, but also manipulating or do trigger actions in the environment. And this could also be a fully virtual environment, so it does not have to be always embodied AI systems or anything. But it's important that there is some interaction with the environment, with the surrounding of the system. And in the end, the system has to operate in a goal-oriented way. So it has to trigger goal-oriented actions, or it triggers goal-oriented actions. So it performs certain actions or tasks to achieve a specific goal. So this is what I would say if you really want to check. So if someone says, here is a cool agent, I would always say like, okay, there's no clear definition of what an agent is. There's no, okay, now then this has to be in there. So it's an agent. It's more a scale. And I think it's better to think more in terms of a continuous scale of agency and there's systems with higher agency and lower agency. And everybody has a threshold where they say, okay, it's above this threshold, so I call it an agent, but this threshold is very subjective. So I think it's not very useful to discuss when a system is exactly an agent. What's very helpful is to think about and to check for those criteria. So if someone says, here's a cool agent, agentic system or a cool agent, then ask yourself, so what is the level of autonomy? Is environment interaction, what complexity of environment interaction? And does it operate in a often multi-step, multi-task way to achieve a specified goal? And then you could say, okay, if this is all the three components are there and also in a complex and sophisticated manner, then at some point you could say, okay, this is clearly an agent, it has a high level of agency, but in the end, let's more look on it as a continuous scale. And also where the upper bound is not really clear. I mean, you could say the moment a system has an agency or the degree of what a human has. I think you could make claims that, for example, an organization is more powerful and has maybe even higher agency if they collaborate than a single human. So there might no be upper bound on this scale. So at some point it might surpass us. At the moment, I would say we are more here, somewhere there, even for the best systems. But obviously, we're doing quite of advancements are happening on that scale, and systems get better, high autonomy, more complex interactions, and able to achieve more complex and more complicated goals. So I mean, hopefully it helped you a little bit to what to look for agents, and be aware. This year, it's really the year for agent washing, like everything. And if you look also at the announcement from our competitors, some of this is what they call agent, I would say. Not so convinced that it has a high degree of agency. Not to say that it does not have value. I think those are two completely independent questions. If an application or a solution has value, it does not need an agent to have value, and also it does not have higher value only because it's an agent. So yeah. Okay, so now we talked a bit about what is an AI agent, and so before we go building one ourselves, I would like to give you some context and also take a look somewhere how it's got started or where it really picked off. So in my view, so one key point for agent is this interaction with the environment. Now with an LLM, the question is, how do you realize environment interactions? Because it needs those interactions to achieve the goal, and then it has to plan or to select the tools to use in an also an autonomous way to figure out how to achieve this goal. So a lot to enable agentic workflows. A lot is also about environment interaction, and those are not trivial to get for an LLM, because we text in, text out, and so where's the interaction happening? And in my view, or one of the more prominent example where this got started or kicked off, it was so-called tool Forma. It was before ChatGPT. It was, I think, 2021. To be honest, I forgot, but it was before ChatGPT. So, and what they did is they took GPT-J. It was an LLM, but they were not trained in this instruction style. So it was not like this prompting, and then you can specify it, instructed what to do. It was more the simple text completion. So it were the raw base models after the self-supervised learning step, where you put in half of the internet as text and then get out the model. So what they did is they trained it within data set where they created where they added tools. So the way it works is the model was trained, and they had created examples and then trained the model, and it was generating, and at some point it would start with such a block. So for example, QA, and then give something here. And then after this arrow, the response was put in by an external system, and then the model continued the completion. So it was inline tool calling, and they did it with a QA tool, calculator, machine translation tool, and the wiki search. And this was like where they really showed, okay, LLMs can understand, want to use which tool if they are. This was specifically trained for those tools. So they created training data, trained the model, and then it worked. But it was the first sign, okay, LLMs can reason and think about and select tools to come up with solutions for new problems, or help in coming up with solutions for new problems. So this is where I think, or in my view, it really got started, and was really mind-blowing to see back at the time that this is possible, and that it's able, that the LLM can reason. And now it sounds so banal, but like the LLMs can think about which tool to use, and then actually use it, and also give their own inputs to the tools. And then I think the other pivotal point for agents, is more also in the broader like acceptance or visibility, was when the React agents was launched. It's also a few months older than ChatGPT, but this approach, the paper was released, I think, in October 2022. So 2 months older than ChatGPT, but it was so close together. And then with ChatGPT or GPT 3.5 model, it was amazing what now was possible. And it's very similar, but it came up with a different style of prompting, or like it combined tool calling with chain of thought, you could say. And the difference here was it worked without training for the tool. So you could tell the model what tools are available, and then the model was able to use it. And this is where it really, really picked off. And even today, a lot of agents use this React pattern. And here the idea is you give a question, and then it's not shown here, but in the prompt you also specify which tools are available. And then the model is instructed to follow a pattern of, it has to specify a thought. Based on the thought, it outputs an action. An action is a tool and a tool input. And then the generation is stopped. The tool is evaluated and put in as an observation. And then this is fed into the model again for the next iteration, for the next loop. So you could say it's an LLM talking to itself with tools in the loop. And the tool is added as observation, and the tool output is added as observation, and then it can iterate until it finds a solution or says, okay, solution not possible. And the difference between Toolformer and here is that it works more in this instruction style. It has this chain of thought, like the stepwise reasoning and thinking out loud. And it worked without training. So you could specify it worked completely within context learning. And this is much faster to iterate, much easier to use, and you can combine with a lot of tools, as we will see in a moment. Yeah, and this is probably the most popular LLM-based agent style until today. It's the default model in most frameworks, and it feels like the hello world of AI agents. And now it's time to build our own agent. But as I warned you in the beginning, I have to plug some AI Core Gen AI Hub stuff. So we're going to build an agent ourselves, and we're going to use the orchestration service from Generative AI Hub. And the orchestration service, it's you can do a lot of cool and complex things with it. And later today, my colleague Thomas Schneider is going to give you a deep dive into the orchestration service. And the basic idea is that we offer LLM access, but with additional capabilities like document grounding. Then we have prompt templating module in there. You can do data masking to mask names to prevent bias, and you can add content filter. And all of this you can configure and just use. You don't have to deploy anything here. You get this out of the box as a service from us, and you just have to configure the modules that you want to use. So you can run really complex things in a very easy way, and it's meant for you to build fast and iterate fast and not build yet another prompt templating code stack or deal with data masking, external data masking service and so on. But another thing that it has, and which is extremely cool for building and also for building prototypes, is it has a harmonized API across the different LLMs. And in Generative AI Hub, you get 25 different models from OpenAI, Google, Anthropic. We have open source models. So we have a huge set of different models. And usually they all have their own flavor, their own style, their own API. And in the orchestration, they have a harmonized API. So you see here in this GIF, the only thing that I change in the config is the model name. And then rest can stay the same, and it's called the same code, the same thing is running for different models. So switching between the models extremely easy. And this is what we are going to use to build our agent. So let's move over to the code. I don't know if the link is visible for you in the chat. I will send it again. Hopefully it's visible for you. This is a link to this notebook. The notebook that sorry, I'm a bit confused. My camera is frozen, but I hope you can still hear me and see me. I will just continue. Sorry. And this notebook you can run. The thing what you need is you need an AI core or generative AI hub account or credentials and have them configured for the Python SDK. This is the only thing you need, and the rest you can then run yourself. Yeah, and the idea is here that we build a React agent from scratch. And maybe because because of Sheena, can you maybe send me a message in the chat if you can still hear me, just to make sure that we don't have technical issues.
Yeah,
Okay.
I can
Okay.
still hear you. It's all
Okay.
good.
Okay. Okay. Because for me everything here is frozen, but then I will just continue. Sorry, I will just. So we are going to build a React agent from scratch using the orchestration service. I explained the orchestration service already. So the first part in the notebook is about you need to deploy the service. This is quite simple. You just have to do a very minimal config and then trigger the deployment. So then you have an endpoint to call. This is what we have to do. Here, this code, it looks complicated. You don't have to deal with it. You can just run it. What it does, it checks if already orchestration service is running in AI Core, and if not, it deploys it and waits for it to become ready. So this is just a utility function so that we know, okay, orchestration service is available. And next is we write a small helper function for us to send requests. So here I use the function that I showed before. So it's to discover the deployment, and then here from our Python SDK. By the way, there's going to be a presentation on our different SDKs. So we have a JavaScript SDK now out, we have Python SDK, and we have Java SDK coming soon. All of them will support, and what is available is support the orchestration service. So it should be easy for you to rebuild this in JavaScript if you want to. So here I discover the orchestration deployment, and then here I write the helper function. And the helper function takes a prompt template and some optional parameters to print out so that we can debug a little bit easier. Then the model name, so we can easily switch by sending a request to a different model. And then the keyword arguments are values that we want to put into the template. Here I show you an example. Like let's the Oktoberfest. So here the template is write a haiku about the topic. So this is a pattern to specify a placeholder. So here I can send a request using this template, put in the value for the placeholder, and then I enabled print true so that we can see what we sent and then specify the model. So now let's write a haiku using Llama 370 billion. So this is in the end then what's sent to the LLM. So, or like what the prompt templating module does for you. And then you can get the response, and switching to another model is as easy as putting in a different name. And now we have a haiku written by GPT-4o. So this is the helper function that we will later use for our LLM interactions. So now let's go to building the actual agent. So build the React agent from scratch. And the goal here is it's not meant for you to be used in production, or it's more meant for you to hack with it maybe. And also, I think often you learn you learn best how things work if you build it yourself. So here we build React agent ourselves, and the only thing or framework that we are going to use is the Gen AI Hub SDK, and this only to build this send request function, which is doing basic LLM call. So one thing for agent is that they said is it needs tools to interact with the environment, and with the React agent, we're going to specify which tools are available, what they do, and how to use them as part of the prompt. And then we're going to parse the outputs, take the info, and execute the tool. So we need, and then we run it locally here in the notebook. So for us, a tool is a Python function. And here I wrote a helper class that converts any Python function into a description that we can put into the prompt. So you see here an example. So now the function is add. And when I now put it into create a tool info instance from that function and convert it into string, it prints like this. So it takes the name of the function and the doc string as the usage info, and then the schema is pulled from the type annotations of the function. So this is how we will explain the tools that we have to the LLM later. And for this, we need this tool info helper class to convert the callable into a string that we can use in the prompt. So now that we can convert tools into strings to explain it to the model, then now it's really coming to the heart of a React agent, the prompt itself. And it looks lengthy, it is lengthy, but I will try to guide you through it and explain what the different sections are. So first is some setting the scene. So your help should be helpful to the human and react to questions or requests of the human. And that it's an agent that has a set of tools to its disposal and should use those tools as action to solve the human request. And the goal is to answer the query and basically said it already. And now this part and the most of this here in the prompt is to explain to the model on how to stick to this pattern. So we want to have first a thought, then an action. Action means it has to select a tool and instruct, give tool input parameters. And this is then when we stop, we will take the answer, we're going to parse it, call the tool, and give it back as an observation. And this is then the input to the next turn. And this thought, action, observation flow, this is what we have to explain. And since we have to parse the output, we have to make sure that the LLM follows something like a structure that we can parse. And this is what I'm explaining here, and I repeat and try to make clear that the model really follows this instruction. So here, explain the basic structure. So you see a thought, then it should give a thought, then the action block. And the action block here is then as a JSON blob. And then here will come the observation. This part is obsolete. I just saw now. Let's remove it. Okay. No, hopefully I did not broke it. Sorry. I removed this part. So now the next step is to explain the tools. And here you see the placeholder, and this is where we're going to add the tools. Yeah, so this what we will fill later. And I just decided to keep it in here because then I tested it works and then we can remove it and see if it still works together. But I will leave it in here so it I don't break it right in the beginning. And then it's explaining how this tool part looks like. So the JSON blob structure should be name of the tool, and then the input. And here again, repeat what the tool names are. So here should go in the tool names, and then here a JSON that follows the schema for the tool. And then I just put the two pieces together, give a recap, explain that this is going to repeat. And then what I just changed because it's closer to the paper. So I think, for example, the LangChain implementation does it a little bit different. So the question is, how do you break the loop? So when do you finish? And usually what you do is you put an upper bound, a hard limit, so that it cannot get stuck in an infinite loop. But at some point, the LLM has to actively decide to jump out of the loop and say, okay, I know the answer. There's a final answer. And in the first version that I implemented, and also I think it's done like this in LangChain, is that there's, instead of giving an action, it gives a final answer as a special tag here. And then it's parsing the answer, looking for final answer, and then we break. But in the paper, they do it a little bit different. And it's from implementation wise, it's a bit simpler, a bit shorter, is we simply introduce a special tool, a cool tool called finish. So the model can call this tool. So it's the same parsing, and the input to this finish tool is the answer. So this is what I changed, and I just realized that there's some part of the old versions in there. But so the breaking is happening now with a special finish tool, and the input is the final answer, and this is then taken as the answer. And that's basically it. So you see all of this is just to make sure and explain that the model follows the structure and the flow. And then, yeah, here we have the input for the query. And then we have here a placeholder for the scratch pad. So the scratch pad is if we do multiple turns, so the results of the previous turns are then put into the scratch pad and visible to the model for the next run. But you will see this in the code, how it works. So this is our prompt, and this is like the React agent has two core pieces. So one is the prompt, like setting the flow and so on. And the other is obviously the code surrounding and calling the tools. And now we need code that does a few things. So first, it has to call the LLM. So we have to send the request. It has to parse the response, look for the tool, for the actions of the tools, and then execute the tools. And then depending on the output, it has to trigger a new agent loop. So next iteration with tools, or if the finish tool is called, it has to break out of the loop. And here we now implement those functions. Here first some helper functions. So this one is to extract the JSON blob from the LLM response. So we extracted it to encapsulate it in 3 backticks. Some models, just because they are trained on it on Markdown, they add a JSON, like specify the type of the code block that is coming. So we extract both with and without the JSON tag. But basically, we are looking for blocks encapsulated in 3 backticks. And then we just load it as JSON and return it as a dictionary, and then it can be used. Here, this is about extending putting the observation together with the response. It looks a bit more complicated because sometimes the models, they give observation as the last output of the response, sometimes not. So we need some fuzziness because to keep the structure. So it's basically checking the response and whatever is given here as a prefix. So if the model already put out observation as part of the response, it will keep it and just append what the result was. If the model stopped after the action block, it will append the observation. So it have some coherent flow or like structure in the scratch pad. So sometimes the model gives this as part of the response, sometimes not. So this is why we need a small helper function that can deal with both. And then we have a small function just for us to check on the scratch pad to see the steps. You will see it in a second. Yeah, and then as I explained already, like some point we have to decide how to break the loop, to get out of the loop. And here, this is where I define this special finish tool. So you see it's a callable finish giving the answer, and it just raises an exception, and this exception we will catch to give the final answer. Okay, so we had the prompt, the helper functions. So now let's talk about the real agent part of the agent itself. So we initialize it with a set of tools, so a list of callables and a model. And then we use our tool info to get the strings for the prompt, for the placeholders, and also store the actual functions so that we can call them later. And then it's the loop for the agent. So we initialize an empty scratchpad and we count the turns it takes to give an upper bound so it cannot get stuck in an infinite loop. And then we run this until we return a value or we reach the maximum number of turns. First is sending the request. So we use our prompt, we set our model, debugging, I set it to false, otherwise it will just print everything full. So we don't use any debug print. And then we give the placeholders for the prompt. So first is the query. This is the input. This is what the user requested. And then in the scratchpad, we store a list of action for observation of the individual turns. So we just join it with a new line so that we have a text block for everything that was happening before. Then the tools, and this is what we looked at the beginning. So it's converting the tool into a string, and we just join it with new lines. So we have a block describing the tools. And then we have a list of tool names because we use it in multiple places in the prompt. So those are the placeholders. Those here are static, and the scratchpad is what is changing from turn to turn, and where the model can see what was happening so far and can build on the results of things that happened previously. And then we get the response. It's a string, so we have to parse it. And then we try to parse it, extracts the JSON from it. This is then a dictionary with the keys name and input. So name is the tool that we want to do, and input are the arguments for the tool. So we store the callables in the tool dictionary. We pick out the correct tool and then call it with the input arguments. And then we get back the observation. And here we catch, if the tool call raised the final answer exception, we expand it to the scratchpad to have it complete, and then we return the answer, the text of the final answer is the return value. And we always return the result in the scratchpad, and the scratchpad for us to take a look of what happened. And then here I added some, I don't know, hopefully not, but sometimes the model does not fully stick to the schema or does something wrong. But the cool thing is, since we have the LLM in the loop, we can use the LLM and let it try to fix the issues. So this is why if this here went wrong, so if the JSON is not correct or the tool triggers an error, I catch the exception and give this as the observation. And then in the observation, we'll say error when calling the tool, and then I give the last 10 lines of the traceback. And then if it happens, sometimes the agent can fix it because it sees what the error is, and then it can react and change. And the next time when calling the tool, the agent can change the input parameters, fix it so it works. So this is just our thin line, our fallback. And everything here is just for educational purposes. So in the real world, you would maybe use some JSON mode of the model, so to make sure it follows the schema, or there's some function calling helper with things in the OpenAI API. But here's, we take the plain model input, output, and to learn how it works. Okay, I see that I have to hurry up a bit. So hopefully this is now clear how we implement it, and that it's not that complicated. Now let's use it. So as you know, LLMs are amazing, but often they are not good with mathematical calculations. So now we equip our LLM with some math tools, simple math tools: add, subtract, multiply, divide. And now we ask the model, what is the result of this equation? And it takes a while. And then let's see, I hope I executed all the cells before. Okay, so now we have it finished. Oh, I forgot to send the result. So let's print the result. So the result is 5. Okay, so now we can take a look into the scratchpad and follow and see if it does it correctly. So the first thought is, has to evaluate the expression, and then I need to follow the order of operation. So it understood that it has to follow the operation. First, I will multiply 5 and 2, and then add 5 and finish subtracting 10. So the first action the model does is calls the multiply tool with 5 and 2 as input. You can see it's AB int, so it understood the schema and called it. Then we add the observation 10, and then it's a new call to the LLM with this block here in the scratchpad. And then the new thought is, now that I have the result of the multiplication, I can add 5 to it. So it calls the add tool, 15. If the result of the addition, I can subtract 10 from it. So it calls the subtract tool, comes to 5. And then it calls the finish tool to say, okay, I know the final answer, and the answer is 5. And then this is what we return. So you see, it really worked, and it really understood on how to use the tool, when to use the tool. And the cool thing, it can combine it with its general knowledge here. It can combine it with, okay, I know how to call the order, that I have to take care of the order. So it did so. But doing elementary math is not, it's a bit lame, so we can do better things. It was a lot of cool tools need some API key and maybe come with some free trials. So often Google search is used, but Google search, you need some API key for it. There's a free plan, but I wanted that you can use it without signing up anywhere else. So I went with Wikipedia. So Wikipedia wrapper, this is just a function here that you can run a Wikipedia search. So here I search for SAP, and then it takes a while, but you get this as an output. So I cropped it so you get the first 500 characters from the pages found here. So now I just have a very important task. So I want to know what the age of Barack Obama multiplied with 1,000 divided by SAP founding year subtracted with the age of Taylor Swift subtracted by 437. So it's super important for me to know that number. And we can send it directly to the model and see what the model does. Okay, it comes up with, to be honest, I was surprised how good it does it. So it really understood what to do, and it gave an age for Obama, age for Taylor Swift, and then did some math here, and the math was more or less correct. I mean, it's doing some rounding errors, but, or not rounding, it does some strong rounding, but I was surprised, to be honest. Like if you do it with older models, like GPT-352, it will look much worse. This is here, by the way, always Llama 70 billion that I'm using. Okay, so this is the baseline. So this is what the model does without any tools. So now we take our math tools, and we, as an additional tool, we put in our Wikipedia search. Now let's run it, and it takes a while. You saw that the Wikipedia search is slow, but in general, like AI agents, it takes a while because you do a lot of turns, which also increases the cost. So you can do amazing things with it, but be careful, like the cost can go up extremely high, and you will have some fuzziness in the agent that is sometimes problematic if you want to move into production. So general guidance is only use agents or this kind of workflow if you really need it, if it cannot be solved with classical software, whatever can be done with classical software. Stick to a classic implementation, don't go fancy if not needed. It will backfire because it's slow, expensive, and unreliable from time to time. Okay, so now we have the result. So first is, let's look up Barack Obama. So it puts out the Barack Obama. Next, okay, I found Barack Obama's birthday. So it needs to calculate his age. Okay, then it does subtraction. And this is one issue here. It doesn't, the LLM doesn't know what the current time is. So it takes 2023 because it was trained in 2023. Then it does looks up SAP and finds the founding year in here, looks up Taylor Swift, then subtract observation, then it multiplies Barack Obama's age with 1,000, then it subtracts, okay, so it does the call wrong. So when calling the tool, okay, and then this is what I meant, like we catch the error. and the model this was given as a response. And then it was, okay, it's wrong, it's not correct. And then it's, okay, I need to correct the input for the subtract tool. So it subtracts it here first, puts it in, does it correct? So does the tool call correct the second time, get the observation, runs the divide, and has the final answer. Okay, this answer is not rounded, but it's similar to what we saw before. But for me, it looks wrong. And the reason it's wrong, it's the date is wrong. The age is simply wrong because it doesn't know what time it is, what day we have. So let's give it yet another tool. So now I give it a tool today, and it's to get today's time. And now we can run it again. And while it does so, I will just continue with the slides, and we can jump back later and see if the result then is better. So yeah, so we built it from scratch, and I hope it was like what I want to show you, that it's not that complicated. It's actually pretty intuitive how it works, and it's also amazing to see how well the LLM understands, or how good LLMs are nowadays in understanding what tools are available, when to use the tools, how to use the tools. I mean, this is all new tools, nothing trained here, just using LLMs out of the box. And if we would have more time, we could test it with different models. Yeah. So coming back to the result of the beginning, and now let's demystify this a little bit. So what we built there is, like, the idea was we want to fulfill user requests, and our tools are some SAP systems. And as tools, we did not, okay, there's so many systems, we cannot put everything into implement a function for every tool. So what we said, okay, what we do is we have it HTTP request tools, so very generic tools. And as input, the model gets to see the API spec. There's an API hub from SAP, and there you can download for all the systems the API spec. So this way we can integrate a lot of systems without coding for every individual system. So we downloaded all API specs, and in the demo we used, I think, 300 or 400 or 600, I forgot, but a lot of those. And the idea was, okay, we use the agent and let it learn from the API spec what to do in the calls to fulfill the task HTTP tools. So no implementation, no specification for any specific system. And so we start with a huge action space. So a lot of different tools are available, a lot of different systems. So first is we put a retrieve step up front. So based on the user request, we filter the API specs with an embedding, with a rack approach now, and retrieval approach using embedding model to get to a shorter list of API specs. It's mostly to manage the prompt input length, because if you put 300 API specs into the prompt, it's just too long. So we have a retrieve step up front. And what we do slightly different, we let the LLM specify a plan up front. So based on the API spec, it should specify a plan. This is also mostly to stay coherent, and also in the plan, it selects the API calls it wants to do. And this is also then in the execution, which is a React agent, we can give more details on the individual calls. It's again to manage the prompt, and it does not explode, because in the API spec, every endpoint has like 20, 30 lines of explanation what it does. If we do it for, I don't know, 100 endpoints in an API spec, it's just too long. So it's mostly to filter the action space and to manage the prompt input length. But then the execute is what we just saw. It's a React agent. So I will quickly run through some example. So we saw this. So it sends, we want to create a manufacturing order. And I jumped too far ahead. So we send it, and this you see the retrieve spec. So it retrieves the API spec, a production order. It's an cryptic name from the API hub. I don't know. Then you see it ran the plan, and now it's in the phase of executing the plan, doing the React, what we just saw. I will stop for a moment with calling the tools. So here's the intermediate result of the planner. So this is coming up with the plan up front. It helped us a little bit that it stays more coherent and sticks to a plan. So this is why we have a dedicated planning step. It's also like plan execute is also, I would say, after React, it's the most typical agent flow, and often you can combine it. Yeah. So we have a plan, and then it's into this execute plan, which is a React agent. And hopefully I open this here so we can see some of the actions. Yeah. Or not. Okay. Yeah, okay. So here you can see this is similar to what we saw before. So now everything is a step, and you see it's printed a bit different. So it took the post tool to this endpoint, and this is the request body. So the tools are specified a little bit different. So the tool is what kind of call you want to do, which endpoint, and then giving the payload for the request. And this is all generated by the LLM and learned from the API spec. And then also to manage the prompt, we extract from the output. So you give an output instruction to condense the output, but it's a minor detail. So now it ran a post request to this endpoint with this payload and get back a result. And this is enough for this simple request. So it's a simple single call it has to do. But then I will talk too much about the code because I'm always, I always like the hands-on part most. So I have to hurry up a little bit. So then we do the same. Now we retrieve the manufacturing order that we created to double check, and then it understood same API, different call. So it has to call a different endpoint. So it does a GET request. So the tool is now the GET tool to this endpoint. And we can retrieve the manufacturing order that we just created. And then we do something, same agent, same setup, nothing has changed. We do something, a completely different task. So now we ask, get all AI core deployments with starting running from scenario ID foundation models, return the model names and the configuration. So this is now the same agent, completely different system. And this is now AI Core, the product that I'm working for. And this is basically the question, which LLM deployments did I do in my account? And so same principle, we retrieve the API spec. Now it's a different API spec. We go to a planning step. It's a bit more complicated, the planning, and also the execution is now a bit more complicated. So sorry that I'm rushing through it, but I hope you got the idea here. And now you see it does a lot of more calls because there's multi-step. It has to get the configurations and then check on the individual configurations. So it runs a lot of calls, but this is the same React loop that we saw before, now with just different tools, the HTTP tools. Okay, so let's come to an end. Yeah, I hope you now had a better, like slightly, I don't know what the background of it, I know, like very different backgrounds, I guess. So it's now we took a look under the hood for agents. We built a React agent ourselves, and then we demystified a bit this API agent demo showcase that I did, and to show how to do more advanced AI agent stuff. And this is, I would say, this is on this arc on what to do and what are more advanced things. And also, I think later today or tomorrow or next week, Karim, a colleague of me, is also talk a bit about fine-tuning. So prompt existing models, I guess everybody did it today. So now the next step would be agents or fine-tuning, where you get some insights from us during the Devtoberfest. And then afterwards, it's more about building our own model. And this is also where we as SAP are already working on. So here you can find a blog post if you're interested in those topics as well. You can find a blog post on fine-tuning. And here you can find a blog post on structured data, how SAP utilizes structured data and will train a structured tabular data foundation model. So the same paradigm as for LLMs, but now for tabular data. Two very interesting blog posts, in my opinion, where you can read up on some of the details of what we are doing in the AI unit of SAP. And now, before we open the round for questions, let's take a quick look if the answer now is correct. Yeah, so obviously the answer is 42. And it does 42 because it uses the today tool to figure out what the current date is, so it can calculate the ages correctly. So it understood that it has to use the proper date, and then also we get the correct answer. Yeah, so I took much longer than expected. I'm sorry, but still, I think we have some time left for questions.
Thank you, Matthias. That was a wonderful session. So to the participants, if you have any questions for Matthias, you can post it in the chat now. Or people who are watching the recording, if you have any questions, you can post them in the comment section of this video or in the SAP community page, and we can get back to you. So maybe, Matthias, we can wait for some questions.
Sure.
Yeah, so we have a question now.
I cannot see it. Where is it? In the meeting chat?
Okay, it's in the YouTube, so I can read it out for you. So the question is how to provision generative AI in BTP.
Okay, yeah. Generative AI Hub is part of AI Core. So in BTP, you have to provision AI Core. It's if you provision AI Core with the extended plan, I assume you're external, so it's the extended plan for external. For internal, there's a SAP internal plan. Use this as an SAP employee if you work for an LOB in SAP. If you're external, use the extended plan. Yeah, and then you get Gen AI Hub out of the box. It's part of AI Core. It's then you get all the things that we shared here, the orchestration service, also the things that my colleagues are going to show. It's part of AI Core, and this is what you have to do in BTP, provision AI Core.
Okay, so there is another question. Can you please share the link to the notebook?
Yeah, I mean, can you send it maybe to the YouTube chat? I don't have it open, the chat. It's in our meeting chat. You can find the link to the notebook.
Yeah.
Um,
So yes, I can do that. So both of them, Mathis, or
no,
the
it's
second one?
the same link. It's two times the
Oh,
same
okay.
link. I wasn't aware that I
Okay.
have to send it to the YouTube chat.
Mhm.
Yeah.
Yeah, so there you go. Just a second. Okay, so this is the link to the notebook. Okay, so we have some comments and some few other comments in the chat. So yeah, I think it's about the session. You can watch it later as well, Mathis. So I think we are at the top of the hour, and in case you have any questions, this is for especially for the people who are watching the presentation or recorded version later. You can always post the questions in the comments, or you can go back to the community page and post the questions there against the session. And we can get back to you as early as possible. Okay, so yeah, I think with that we are complete. So thanks again, Matthias, for this wonderful session, and thanks everyone for participating in the DevToberFest Math Thursdays. And please do not forget about the validation tutorial that will be updated in the description box of this video by the end of the day. And we'll also share the presentations shown by Matthias by the end of the day today. So don't forget to check it out. And thanks again for everyone for attending this session. Take care and bye.
Bye bye.